Alright, so here's how to work number 21 and 22 on page 248. This is a pretty complex proof, but it's not that difficult. There's just a couple tricks to it. First thing we want to do is we want to prove that S is the midpoint of segment BK. Now, they already give us two sets of congruent segments, or congruent sides in this figure. And if we look here, and let's assume for a second that S is the midpoint of BK. Well, what that means for this figure, if S is the midpoint, that means it cuts this segment in half. So if we can prove that SK, that segment, is congruent to segment SB, well, then that'll be enough to essentially say that S is the midpoint of segment KB. Because if it's the midpoint, it'll cut this thing in half. It's actually going to be helpful to sort of ignore that one detail for a second. The fact that KB even exists, let's overlook that fact. If you notice, we kind of have two triangles that look to be congruent. So let's draw those without the KB segment. Alright, but I'd like them spread out more, so let's separate them a bit. If you notice, they both overlap on segment AE. So you could say that segment AE is going to be congruent to the other segment AE. And the reason you'd say that is going to be the reflexive property. Since those are congruent, that means that these triangles are congruent. So you can say that triangle AKE is going to be congruent to triangle, let's call this one ABE. So now that we have that those two triangles are congruent, that means every corresponding angle in those triangles is congruent. So you could say that, alright, well, this E matches up with this E, this angle A matches up with this angle A, this angle B down here matches up with this angle K up here. So all the corresponding pieces of those triangles are congruent. I want to focus on one of those details in particular, particularly these angle E's right here. I'm going to notice that angle KEA, which is the angle on the top triangle, the first one I list. So angle KEA is going to be congruent to angle BEA. And the reason I know that is because, well, the triangles that they're a part of is congruent. So you would use the corresponding parts of congruent triangles, the fact that those are congruent, for your reason there. Now that I have that, I can kind of get back towards saying that S is the midpoint of KB. But first focus on either these two triangles on the right or these two triangles on the left, on the top and bottom respectively. I want to focus on the ones on the right. You can do the similar proof for the ones on the left. I want to prove that these two triangles are congruent, because if I prove that these two triangles are congruent, that means that this corresponding side, SK, would be congruent to this corresponding side, SB. The way I prove that is, well, I draw these separately. I notice that, hey, look, they share a side. So you can say that segment SE is going to be congruent to the segment SE in the other triangle. Well, since we already said earlier that angle, this angle E over here was congruent to this angle E over here, well, that means that you have side, angle, side. So you can say now that triangle KES is congruent to triangle BES. And since we have, these triangles are congruent, that means all the corresponding pieces of that congruent. That means that segment SB is congruent to segment SK. So you can say SB is congruent to segment SK. And again, that's by the corresponding parts of congruent triangles are congruent. Since S is in the middle of, it cuts these in half, it's literally in the middle, which you can see since the two sides are congruent. That proves that S is the midpoint of segment KB, or segment BK. Alright, that's the first part of our proof. The second part follows. We've already proved that S is the midpoint of BK. To prove that these little intersecting diagonals here to this figure, these intersecting lines are perpendicular, well, I already know that these triangles are congruent, so I proved that this triangle here is congruent, this top triangle is congruent to this bottom triangle, so I called it segment KES and BES. Since those are congruent, that means the angle S in both of these triangles are congruent. But also, I know that they're supplementary because I make note that, oh, angle KSB, which when you draw it together looks like this, angle KSB, it's a straight angle. So I notice that angle KSB is, the measurement of that is equal to 180 degrees. Oh, but since, we know that those two triangles, when you draw the segment ES, since that bisects these two triangles, like bisects this big triangle to two triangles, well, that means that angle KSE, or you could say the measurement of angle BSE, is equal to 90 degrees because it's congruent and it's supplementary, and we know that because that's the congruent supplements theorem. Or you can put it in your own words and say that, oh, well, they're not only congruent but they're supplementary, so if you're both the halves of 180, then that means you're 90. So that proves that since these angles are 180 degrees, when you go back and you look at your triangle as a whole, if KSE is 90 degrees, so we can go on to this original figure here, and in the KSE we can draw a little right angle there. Well, that proves that segment KB is going to be, or segment BK is going to be perpendicular to segment AE. And that's how you do this proof. It's kind of lengthy, but one piece follows from the other, so you just have to sort of find the little tricks in between. So try working that out.